H. C. Verma, Concepts of Physics. Wave motion and waves on a string. Exercise question 22. Let us look at the setup. A pulley is mounted on the ceiling. A string passes over the pulley. On the left side, a 2 kg block hangs 25 cm below the pulley. On the right side, the string goes straight down to 0.0 meters to the floor. The total string has a mass of 4.5 grams. A transverse pulse is produced at the floor. Watch how the pulse travels upward along the string towards the pulley. We need to find how long this takes. Here is the question. In the arrangement shown in the figure, the string has a mass of 4.5 grams. How much time will it take for a transverse disturbance produced at the floor to reach the pulley? Take G equals 10 meters per second squared. The key concept here is the speed of a transverse wave on a string. The wave speed depends on the tension in the string and the linear mass density. The formula is V equals the square root of T over mu. Once we know the speed, the time is simply the distance divided by the speed. Step 1. Write down the given values. Mass of string M equals 4.5 grams, that is 0.0045 kilograms. Mass of block equals 2 kilograms. Distance from floor to pulley, D equals 2.0 meters. Distance from pulley to block equals 25 centimeters, that is 0.25 meters. And G equals 10 meters per second squared. Step 2. Find the total length of the string and the linear mass density. The total string length is the floor to pulley distance plus the pulley to block distance. That is 2.0 plus 0.25, which gives 2.25 meters. The linear mass density, mu, equals mass divided by total length. That is 0.0045 divided by 2.25, which equals 2 times 10 to the power minus 3 kilograms per meter. Step 3. Find the tension in the string. The tension equals the weight of the hanging block. T equals M times G, which is 2 times 10, giving us 20 newtons. Step 4. Calculate the wave speed. V equals the square root of T over mu. That is the square root of 20 divided by 2 times 10 to the minus 3. 20 divided by 0.002 equals 10,000. The square root of 10,000 is 100. So the wave speed is 100 meters per second. Step 5. Finally, calculate the time. The pulse travels from the floor to the pulley, a distance of 2.0 meters. Time equals distance divided by speed. T equals 2.0 divided by 100, which equals 0.02 seconds. The correct answer is 0.02 seconds or 20 milliseconds. That is incredibly fast. The pulse covers 2 meters in just 20 milliseconds because the wave speed is 100 meters per second. Here are some important exam tips. Tip 1. The tension in the string equals the weight of the hanging block, not the total weight of the system. Tip 2. Use the total string length for calculating linear mass density, including the portion from the pulley to the block. Tip 3. but the distance the pulse travels is only the floor-to-pulley length, not the total string length. Tip 4. The formula V equals root T over mu is valid when the tension is uniform throughout the string. Here the string is light, so we can treat the tension as uniform. Like and subscribe for more H.C. Verma solutions at MAGPIEHUB. See you in the next video.